Organic molecules found on Mars. The discovery of organic compounds on Mars marks the first time ever, and it has significant ramifications for space science. This is a new scientific breakthrough, with scientists only recently detecting organic chemicals on Mars. This is a significant discovery because it raises the possibility that there was once life on the planet. Whether there is life on Mars, which has baffled scientists for decades, is about to be resolved. What do these organic molecules represent? And what can they teach us about the likelihood that life exists on our neighboring planet? Join us as we examine the implications of NASA's fascinating discovery of our knowledge of life in the universe. After 550 Martian days of trundling around the Jezero crater, NASA's Perseverance rover has collected over half of the rocks it was intended to collect, some of which contain organic compounds, suggesting that life may have been there more than 3 billion years ago. These substances are likely essential for the emergence of life since they contain carbon and frequently hydrogen or oxygen. The focus of this video will be on organic compounds found on Mars. Please give this video a thumbs up and subscribe to this channel for more, just like before we continue. Click the bell icon to receive notifications of new videos. Did you do that already? Let's begin. Since it landed on Mars in 2012, the Curiosity rover has been looking for biosignatures or evidence of former life. Mars consists mainly of dirt, dust, and gas, yet it may have once included lakes, rivers, and microscopic life. Curiosity found ammonia and the chemical compound benzoic acid in the sample it took from the Bagnall dune in Mars. Still, it did not find any biosignatures, which are traces of earlier life. Ammonia was notable because, although not an organic component, the researchers thought it might be a biosignature signal. What are the organic molecules found on Mars? NASA's Perseverance rover has accomplished so much on Mars in just 1.5 years. The agency gave a briefing to review highlights from the science mission thus far, and it was a celebration of rock samples and discovery of organic materials. Biosignatures or compounds that could have come from a past life on Mars are molecules like organic molecules like benzoic acid. These results also point to the potential of this sample collection technique. The NASA team that conducted the wet chemistry experiment published its findings in Nature Astronomy. Previously discovered organic compounds on Mars were from sedimentary rocks and included thiophenes, benzene, toluene, and short carbon chains. These chemicals were discovered using Curiosity's specialized ovens, which heat sediment and liberate these molecules. However, this approach has never been used to discover ammonia or benzoic acid. In the wet experiment, Curiosity poured the soil into a mixture of chemical reagents, causing a chemical reaction that allowed scientists to identify the compounds in the mixture back in the lab. Do organic molecules include the presence of life on Mars? Do organic molecules indicate the presence of life on Mars? The latest discovery of organic compounds on Mars raises the possibility that there was once life on the planet. However, since the existence of these chemicals does not always indicate their origin or source, they could be from meteorites or other non-living sources. We are not yet in a position to draw any firm conclusions about whether or not life is present on Mars. Before we conclude whether life exists on Mars, we need additional information. One of the exhibition stars was a rock called Wildcat Ridge, which could be found in the Jezero crater's historic river delta zone. 2 samples were successfully taken by Percy from the mudstone rock. The organic compounds known as aromatics present in Wildcat Ridge are considered potential biosignatures, which NASA defines as a substance or structure that could be proof of past life but may have been created without the presence of life. The rover team noted that the discovery of organic materials does not imply the discovery of signs of prehistoric life. The Curiosity rover in Gale Crater and Perseverance, which discovered carbon-containing molecules early in the mission, have previously discovered organic molecules on Mars. The Sherlock instrument on the rover examined the rock. Sherlock scanning habitable environments with Raman and luminescence for organics and chemicals. According to NASA, the Sherlock instrument recorded the most abundant organic detections on the mission to date in its investigation of Wildcat Ridge. In their investigation of Wildcat Ridge, researchers are spotting some recognizable patterns. According to Perseverance Project scientist Ken Farley, in the distant past, The sand, mud, and salts that currently make up the Wildcat Ridge sample were deposited under conditions where life may have conceivably thrived. Significantly, the organic material was discovered in a sedimentary rock known for holding onto remains of extinct Earth life. Perseverance is not equipped to discover definitive evidence of ancient microbial life on Mars. During the news conference, Farley stated that the bar of proof for establishing life on another planet is very high. To do that, we must analyze Mars rocks in person and up close in laboratories on Earth. An unusual chemical compound found on Mars and analysis. Martian rivers and lakes may have once flowed despite the cold and arid planet. According to scientists, the planet may have once supported ancient microbial life during its early history and may have been habitable. On Mars, researchers explore for biosignatures or specific compounds that may have been produced by past or current life, whether it be microorganisms or something more complicated, to find that life. Additionally, researchers look for organic compounds. Organic molecules are thought to be the building blocks of life on Earth and may be found elsewhere in the cosmos. The new discoveries add to the list of organic compounds on Mars and support the idea that Mars was once habitable. The Curiosity rover has already found organic molecules buried in Martian soil. Even though none of the organic molecules found in the sand are definitive proof of life, they do show that the new method, which did not require the rover to drill, is a useful one for looking for carbon-based chemicals, which are essential for the existence of life as we know it. Curiosity encountered a metaphorical snag when searching for evidence of life on the Red Planet at the end of 2016. This was when the wet lab experiment was born. While Curiosity was on Mars, Vera Rubin Ridge at the foot of Mount Sharp, the drill malfunctioned. The mission crew decided to take an alternate path after the rover gathered a Martian soil sample. Instead of placing the sample in one of the cups on the sample carousel, they placed it in a cup that had already been pre-filled with a chemical mixture. As a result of subsequent trapping and analysis of the molecules released from the cup, it was discovered that Mars has organic chemicals that no previous spacecraft had discovered. The researchers described their findings in a paper in Nature Astronomy, according to Mava Milan. The experiment's original purpose was to serve as a reference for subsequent chemistry tests carried out on samples from Mars. According to Milan, this experiment was undoubtedly successful. We demonstrated that this technique is highly promising, even though we haven't found the biosignatures we were hoping for. NASA to do additional research. The Sample Acquisition, Processing, and Handling, SASPAH, pronounced SASPA, system, a collection of devices gives Curiosity unheard-of capabilities for interfacing with the Martian surface. Collection and handling for in situ Martian rock analysis, CHIMRA, pronounced Chimera, is the new name for the sample scooping, sieving, portioning, device, robotic arm, and turret part of the SASPA. The dust removal tool, DRT, commonly known as the brush, a collection of stationary hardware attached to the front of the rover to support drilling and sampling operations known as the sample playground, as well as motorized inlet covers and spring-loaded wind guards for the instruments, are also included in SASPA. 12 rock samples, including fragments from Wildcat Ridge and Skinner Ridge, a different sedimentary delta rock, are currently aboard the Percy. Earlier in the mission, it also obtained igneous rock samples that indicate the impact of long-ago volcanic activity in the crater. In anticipation of the upcoming Mars sample return campaign, NASA is so pleased with the variety of samples that it is considering releasing some of the filled tubes onto the planet's surface shortly. MSR is a bold idea to send a lander to Mars, collect Percy's samples, launch them off the planet, and return them to Earth for in-depth analysis. The mission is still being developed. Those rocks could arrive by 2033 if everything goes as planned. Because MSR is so complicated and significant, NASA and its collaborators are figuring out ways to ensure the samples can be collected. Perseverance might remain in fine working order when the MSR lander arrives, allowing it to meet and provide samples directly. MSR will have another chance to bring the priceless pebbles aboard by leaving some samples at a cache site in the crater this early in the mission. Percy has been gathering samples in pairs. It might, for instance, hold one Wildcat Ridge tube on board while letting the other fall to the ground. It is fantastic that we are only weeks away from deploying Perseverance's interesting samples and just a few years away from getting them to Earth, so scientists can examine them in great detail. We will learn a great deal. There might be life on Mars. We can't say for sure yet though, because we only have one data point, and we need multiple data points before we can make any conclusions about whether or not there's life on Mars. The organic molecule we detected could be due to contamination from Earth, or it could have been created by non-living processes like chemical reactions caused by heat or pressure. So while this is exciting, it doesn't mean there's life on Mars yet. We need more evidence before we can say anything. We have come to the end of this video. Do not forget to give this video a thumbs up and subscribe to the channel to see more content like it. Do not forget to click the bell button to receive notifications when new videos are posted. Till the next video, bye for the moment.